In this video, I'm going to take you through the steps to create code to do an image segmentation operation. I've opened up Matlab and I've created a new script. And I'm going to start out my code with the lines clear and CLC to clear out any variables that are in Matlab's memory and to clear the output window so I can see clearly what the output is from this code as opposed to other code. In this code, we're going to be doing the following steps. We have to first set up the camera. Then we need to capture an image from the camera. Then we can use that image to go through the steps of image segmentation. The first step is to convert the image to grayscale. The second step is to convert the grayscale image to black and white. In the videos for today, we also had a step 3, which was to apply transformations. We probably won't get to that in the lecture or in the lab today, but there is that step in between. Step 4 then is to follow the object labeling algorithm. Within the object labeling algorithm, there are 3 rules that have to be applied. And once we're all done, we can plot the result. We'll use this outline to fill in the code for each of these steps. The first thing we need to do is to set up the camera. We need to create a video object called vid, and we need to fill in the adapter name, the device ID, and the format. On my machine, the adapter name is WinVideo. The ID number is 2, and the format is MJPG 640 by 480. This may not be the same 3 variables that apply to your machine. If you remember how to get these, please go ahead and get them for your machine. If you don't remember how to get them, please see my other video that explains how to get these variables. I'm also going to end this line with a semicolon to suppress the output. Next, we need to capture an image from the camera. I'm going to start with the line preview vid. That will start the image capture process, and it will begin the process of adjusting the light for the camera. I don't want to actually capture the image until the light from the camera has been adjusted, so I'm going to allow 2 seconds to pass before I capture the image so that the light has been adjusted. Then I can go ahead and capture a single frame. I'll call this variable frame, and I'll use the Matlab built-in function getSnapshot. We want to get a snapshot from vid. The variable frame is a color image from our video, so we now have to convert that color image to grayscale. I mentioned in the videos for today that there are a number of ways to do this, to separate out the color information. I'm going to start by separating frame into each of its individual color components, red, green, and blue. The red component of frame consists of all of its rows, all of its columns, but only the first layer. Remember that frame is a three-dimensional matrix that has rows, columns, and also layers where each layer represents one color. I can get the green image in the same way by taking all the rows, all the columns, but only the second layer. This will give me a grayscale image for red, green, and blue. For now, I'm going to stick with having these three images. Later on, we could go back and use different approaches to convert the image to grayscale. But for now, I'm going to stick with the red, green, and blue images. Next, I have to convert the grayscale image to black and white, and I can do that using the threshold method. I'm going to create three new variables called black, white, red, black, white, green, and black, white, blue. These three matrices will be the black and white images that are based on using the threshold method to convert the red, green, and blue frames, respectively. So black, white, red will be a matrix that consists of all of the values where the red value is greater than some threshold. And for now, I'll set that threshold at 120. This line of code creates a matrix where each element of that matrix, black, white, red, has either a 1 or a 0. The number will be 1 if the corresponding red matrix value is greater than 120, and it will be 0 if the corresponding red matrix value is less than 120. I'll do the same thing with the green and blue images. Before I move on to the next step, I'm going to add a command to plot all of these different images so that we can make sure we have no errors and see that the image looks correct. I'm going to create a new figure window, figure 2, and in this figure I'm going to plot the captured color frame. Then I'll create another new figure window, and here I want to plot the red, green, and blue images. So I'll use the subplot command with 3 rows of plots, 1 column of plots, and this will be my first plot. What I want to go in the first plot is the figure red. Then I'll create another subplot with the same 3 rows, 1 column, but this is the second plot. And here we'll show the green image. And we'll also do one showing the blue image. Right away, I'm also going to create another figure window to show the black and white images. The first subplot here will be black and white based on red, and this has to be inside of an imShow command. The second subplot will show the black and white image based on green. And the third subplot will show the black and white image based on blue. When you run this code, you'll be required to save it, and you'll also be asked to change the folder. You should go ahead and do. Then, several figure windows should open up. One window showing you the live video feed from the camera, one image showing the captured frame in color, another figure showing you 3 grayscale images, and a fourth figure showing you 3 black and white images. Make sure that you get all of these images and that they look reasonable before you move on to the next video. If you have errors or you can't figure out why your figures are not showing the correct thing, call me over at this point.